Let's get a little bit of vocabulary out of the way here as it deals with displacement, which deals with position, where you are in relation to other things. Velocity, which we could say is how fast you're moving, but that's a little different than speed. And acceleration, which is the rate at which your velocity is changing. Okay, calculus and physics get blended together right here. It's wonderful. First of all, S of t is often the function we use, not always, but often the function we use to show the position, also known as displacement. And you can tell from the word displacement that we're basically talking about how far you are in relation to something else, from how far you are from some position, from some set location, we'll call it that, some set location, from ground level, or from, if you're on a number line, how far are you from zero? And it also says from the left to the right, because the negatives and positives. Okay, the velocity is the rate. All right, automatically, when I say rate, you're probably thinking derivative, and you're right. The rate of change of position, and not just rate of change of position, but it is with respect to time. Meaning, we're taking the derivative of some function that is meters or feet or some measure of distance, miles, whatever, and we are talking about how it's moving over time. So miles per hour, meters per second, one of those things, with respect to time. I finished my sentence before I pointed in other places. And in this circumstance, again, rate means derivative, so the rate of the change of position, of course, is velocity. So the rate of change of the position function or the displacement function is velocity. Okay, now we get to acceleration. This is the rate of change of the velocity. Rate of change of the velocity. And again, this is with respect to time. Pen's running out of ink. Oh no, we better hurry. Or switch colors, we could do that. So the rate at which our velocity changes is acceleration. So basically, if I take the derivative of velocity, I get acceleration. I'm going to start this one in the middle. So the derivative of velocity is acceleration. And just backing up a little bit here, that means that if I took the second derivative of displacement, I'd get the derivative of velocity, which is acceleration. Usually the units on acceleration are things like meters per second. So basically meters per second would be velocity, and then per second says, oh, it's changing too. All right, so we're gonna have a number line, not with that ink pen because it's running out of ink. We're gonna have some number line, and we'll have 0 and then 1 and then 2 and then 3. I know this is very basic, I realize that, but this is gonna help us. It's very basic, and apparently I'm going to put the wrong number there, and I don't have my whiteout with me, so we'll just go with it. -1, -2. Forgot how to count backwards. Wow. So basic, you can't miscount. Oh, man. All right, -1 is that one, the one that's so smudged, but obviously you can tell that from context clues. So if I'm talking about displacement, I might be talking about where I am on a number line. So it's where I am from some set location, which usually is 0 in this case. Or like I said, if we were like diving off a diving board, how high are we off of the pool level or ground level? If you're jumping off a cliff safely, you know, one of those things. So the number line is going to help us really discuss this, and often you'll see these problems in context of a particle is moving along the x-axis, which sounds kind of ridiculous, but that's their fancy way of saying a particle is moving left or right, and it's not going to have other types of motion with it. That's a different issue altogether. So particles moving left or right, or particles moving along the y-axis, so it's moving up or down. So velocity implies direction. So if I have, there's an ant on the paper. Let's suppose there's a little bug, and he's crawling, and he's going this way. I would say his, in relation to this number line, his velocity is positive, because he's moving in a positive direction. But if the ant was crawling this way, I would say his velocity was negative. Okay, if he crawls off the number line, then we've gotten into parametric equations. It's a lot of fun, but we're not going to play that game right now. So he better stay on the line. Better walk the line like Johnny Cash. Okay, little lame humor there. A particle is moving to the left when, okay, a particle, an ant, or whatever, some car driving. There we go. Going to the left when the velocity is negative. So if I say velocity is negative, that means you're going to the left or you're going down, actually. So let's put a little bit of extra words in here. Or down, basically in a negative direction. And a particle is moving to the right or up when, okay, well, in this circumstance, the velocity would be positive. And so then if we're not moving at all, the particle is at rest, and that would be when my velocity, or the velocity of that particle, is 0. So the ant's crawling and he stops, just randomly decides to stop. And you're like, hey, what's his velocity? 0, because he's not moving. Okay, so then we get into some weird territory when we talk about speed versus velocity. So let's suppose there's an ant and he's crawling and he's going 1 unit. We'll suppose, fake accent just came out. We'll suppose these are 1 centimeter apart, okay? So he's crawling at 1 centimeter per second, right? And he's going this way. And I say, hey, what's the velocity of that ant? You'd say 1 centimeter per second. And then he turns around and he's coming back at 1 centimeter per second. And I would say, hey, what's his velocity? You'd say negative 1 centimeter per second, okay? So velocity can be positive, it could be negative. Again, that implies direction. I think we understand that. Speed, however, is when I ignore the negativity and I just say, this is how fast he's traveling. So what's the ant's speed? Well, he's going in a negative direction, but that's not important when I talk speed. I'm gonna just go this way, and when I go this way 1 centimeter per second, even though the velocity is negative, the speed is positive, okay? Just throwing that out there. As we talk about things that are speeding up or slowing down, we are going to be dealing with velocity and acceleration. Okay, so what I said about speed being different from velocity, kind of a different context than this, but let's transition to this. A particle is speeding up when, okay, and this is a little tricky, velocity and acceleration have here we go. Okay, particles speeding up. Let's suppose we're going to the right and we're gaining some momentum. Let's suppose that I'm going to the right, so velocity is positive. Let's suppose that the acceleration is also positive, so vroom, I'm really speeding up. So if velocity and acceleration are both positive, we're speeding up. Actually, if they're both negative, we are also speeding up. They have the same sign. It's a little hard to visualize in this circumstance, but if the velocity is negative and acceleration is also negative, the particle is going to be speeding up, or the ant, or whatever it is. And particles slowing down when velocity, and you guessed it, you know it, acceleration have different signs. Okay, stuff that's good to know.